So this workshop is essentially on lots of tips and tricks I learned from working in industry during my PhD, from other people that have shared stuff. Some of this stuff I don't do myself, although I should. But I've tried to collect these different things into one pretty fast-paced workshop. So you can try to follow along, and I hope you can, and you do. But what the purpose of the workshop is also to have a reference that you can come back to if you want this specific feature to integrate into your workflow. So I don't know if I said my name, but my name's Eric. So I'm doing a PhD in computer science here. Should be finishing up this year, and then worked at a couple of startups and bigger companies in the past. So last week, who was here for last week's workshop, just to get an idea? Okay, so last week we looked at collaborative coding with GitHub, and we also learned some things about using Git for version control. This week, it's kind of a continuation of that workshop, so we'll revisit some things from last week, and we'll have some reminders on that when needed. But this week is focused on, okay, how can we improve our Python workflow? We're not going to teach how to code Python, so hopefully most of you have used Python and know how to use it. But it's, okay, what are different tools that you can use when developing Python code for your personal projects, school projects, or in industry, or during your PhD as well too. So as probably you have known and seen, Python is pretty much touching every single different field. So just to get a show of hands, how many of you are using Python in your day-to-day, in your project? Okay, so yeah, I guess that's why all of you are here. Good, you're in the right place. So Python, it's really easy to prototype things. So that's what makes it really great. And if I were to compare it to something that traditionally was quite popular in academic and research contexts, which is MATLAB. So in some fields, MATLAB may be more prevalent. What's nice about MATLAB is that there's essentially one interface, one tool, one source for all of these packages, and there's great documentation for this because it's developed by a company called MathWorks. So it's really easy to use. The issues that come up with this, though, is that, okay, because of this centralization that everything is kind of through one company, maybe you don't get the latest trends and features, which is why Python then eventually grew so much, because a lot of it is built off of open source software. And then on that aspect, MATLAB is not free. So when most people leave universities, maybe their company or them individually don't want to pay for Python or for MATLAB. And yeah, essentially Python has the other side of things. It's free, but the issue is there can be many tools to do the same things, which then may make your development environment kind of a bit messy or kind of broken, and you may get into some installation issues. So the goal of this workshop is essentially to make Python as easy to use so you can essentially focus more on building your ideas rather than being annoyed about debugging or things not installing. And then also some aspects on speeding up your code and making it easier to share with others, which links to the previous week. So since a lot of things are based on open source free tools, there's many options, and a lot of what I show here are personal preferences. So it's not the only way to do it. There's really many tools to do the same thing, but I'll try to show a coherent set of them here. But, okay, so if you have your laptops, now would be a good time to take it out. We're just going to do some simple things that we saw from last workshop, and then kind of build off of that to see some Python features. So the slides you can find either by following this QR code with your phone, or if you go to this webpage, pydevtips.readthedocs.io. That will take you to a documentation page where you can then press a button for the slides. So if you're just typing it out on your computer, this is another way to get to it. So just to wait a little bit. So if I click on this, for example, if you were to go on your browser, that would take you to this page. And essentially, it's this button here for the slides, Google Slides. And I guess you just have to go a bit further down to where we are at. All right. Okay, so just for some GitHub reminders. So last week we talked about how GitHub can be useful to initialize your projects, whether it be for Python or for other programming languages. So you don't need to do this now, it's just kind of a reminder. But one thing I often do when I want to start a Python project is I'll start it off as a private repo on GitHub, so I can get rid of all the Git setup from the very beginning. And for example, here I set a name for the project, Python Dev Tips, choose that as private because it's probably going to be very messy, scrappy since I'm just starting the project. So I just keep it to myself or to some collaborators. And the bits that are interesting from GitHub are these templates that they give. So you can start off with some boilerplate code, which you'll want anyway, even if you're not going to use Git in the long term, or GitHub. So for example, they have this git ignore file, which can let you then prevent any, let's say, Python related files that you may want to push to GitHub. Does anyone have some ideas of what those files could be? What Python related files would you want in the git ignore? Yeah. What? Cached or yeah, so cached or compiled files. Anything else? Yeah. Virtual environments. So it puts a lot of virtual environment common paths, so you don't push those environments. Essentially, anything that you can build directly from the code, you want to avoid that being pushed to GitHub. And then you can manually tweak things if you want to add data sets that you don't want to push, model weights, anything that would be too clunky for putting or too heavy in terms of size to put in the repo. So there's that. And the other bit is adding a license here. On the documentation, if there's questions on documentations, I'll talk more about that. But yeah, you can always go back to the previous slides if you want to see more on Git and GitHub, if that's something you're also new to. Okay, so now we're going to go through some of the steps that we saw last week with regards to contributing to an open source project. So the common steps, let's say if you see a project on GitHub that you like, let's say a Python project, would be instead of just going for that git clone option right directly on their repo, the best thing is usually to fork the repo so then that you can make changes to that yourself and also share those changes maybe with some of your collaborators. So essentially the 4 steps are fork or copy that project to your GitHub accounts, make a branch so that you don't touch this main branch, which is like the stable version of the code. So then you can make your own tweaks without breaking that stable version. And then we're going to, instead of cloning the original repo, we're going to clone your fork or your copy. So concretely, what would that look like? So if we're on Python PyDev tips on the GitHub, we would press this fork button there. It would then ask you, okay, which account do you want to fork it to? So here I forked it to LauzHack's account. And then from GitHub, we can make a branch. So just by doing that drop-down menu, and then creating a branch. And then from an IDE like VS Code, so in this workshop, I'm going to be primarily using VS Code. And this is what we saw last week. We're going to do this clone Git repository option to then pull your fork. And instead of cloning the one which was eBESM, so the original one, we're going to clone or download the forked version. And then, as we saw last week, from the bottom of the IDE, we can then switch branches, then switch to this Eric dev branch that we made from GitHub. So just to show kind of from GitHub itself, those options will look like, so this is the original one. You click on this fork. I don't know if it's going to let me. Okay, so then you have a menu like this where you can choose where you want to fork it. I can't do it on this account since it's already there, but then I can fork it to any other Git repo or Git username that I have access to. And then when we're at that fork, so let's say if I go to LauzHack's version, you can just type a random name like random branch, and that will create the branch for you. And then here I already created this actually I didn't create this Eric dev, but let me just create random branch. So that's going to create a random branch now. And I'm on that branch. And then we're going to clone the repo from here. If you don't have SSH install, which we recommended last week, you can just use HTTP and enter your password if needed. But yeah, preferred is SSH. So then that's how you would get this forked or copied version of maybe someone else's Python project to your local computer. All right, can close this one. Any questions on those bits so far? And don't hesitate, even if I don't ask, if you have questions, to raise your hand as well too. Okay. So let's see how we can make our Python development lives easier. So this was a nice article that I found, I think on Medium, where he just kind of gave a list of things to just improve your workflow, kind of avoid headaches. So one of them is using something called a PyProject TOML file. So what this is used for is for installing dependencies in your project. maybe some people are more used to just using requirements.txt, or you would just do pip install all the libraries when you need it. But this is a good way to just make your code reproducible for yourself, maybe if you need to use it on a different machine, but also for some of your collaborators. Another thing is to use a project manager, such as Poetry or UV. Has anyone used one of those before? Poetry or UV? Okay, so we'll show it in a bit. And the other is to use something called a linter or a formatter. So does anyone know what a linter does? Besides Adrien? Yeah, there. Exactly, yeah. So I kind of gave the hint there. So they're essentially tools which help you automate the formatting of your code. So you don't need to manually figure out, okay, where do I need an indent? Where do I need a space? You just write your dirty monkey code, and then it'll try to clean up as much as it can. And for the things it can't, it will kind of force you to do it if you set up something called pre-commit hooks, which we'll also see in a bit. And then there's a lot of other stuff which are very interesting, but we're going to look essentially at some of these ways to improve your workflow. Because one of the annoying things in what a requirements file or dependencies or like a pipe project Tomo can help with is to avoid conflicting dependencies. Because let's say maybe you don't have, you probably are not just working with one Python project on your computer. You may have another one. And then if you install all these dependencies linked to a single version of Python, then your project one may require, let's say, for example, a different version of NumPy than your project two. And then one thing you can do to avoid this is to use something called virtual environment, so that in that environment, you have all the dependencies you need for that specific project. So essentially, we'll see how we make a specific environment for a specific project. So yeah, this is kind of the solution to avoid conflicting dependencies when you have multiple projects. You kind of create these silos for each project where I have these versions of these packages and these versions of another package. So in the PyDev tips, so I put a link to the documentation where it shows essentially how you can create this virtual environment. So go ahead and do this if you have Conda or pip installed. With regards to the differences between them, Conda is usually better to have maybe the more optimized versions for your specific laptop or your specific server, but Python also works. And I wonder, okay, yeah. And later on, we'll see how to use something like Poetry to also automate this. So how many of you use virtual environments in your projects? Okay, so hopefully this is already clear. So then let me move on to then how something like Poetry or UV can help, because it seemed like that was something that was not so familiar with most people. But any questions? I'll just ask just to be sure. Okay. All right. So Poetry. So little disclaimer, when I made these slides, let's say 6 months ago, so like for last semester, I was using Poetry, but now I've switched away from Poetry. But I'll still show you Poetry. But just to show you how there's different options, and sometimes you find something that actually is better. And yeah, I'll show that other version if we have time later at the end of the workshop. But since I'm in the middle of writing my PhD thesis, I couldn't update those slides. So I'll show this version, which is still a great option and better than just using a requirements.txt file. So what Poetry helps with is essentially to package your project. So I'm sure most of you have run a pip install command, like pip install NumPy, for example. So what Poetry will let you do is that you can package your project, let's say PyDev tips, which is the one made for this GitHub, and you can do pip install PyDev tips. So we can install it locally or from a remote server. But it will also let you to install it locally, so that let's say you're working on something that's not on a server like NumPy, you can still package your project so that let's say you're writing some Python scripts, you don't need to do these things like sys.append different paths. Does that sound familiar to anyone? Like you have other files where you've defined functions, and this will just let you to kind of import your source code into your scripts, like the same way you do import NumPy and NumPy.1s, .0s. You can then do that for your source code more conveniently. So some of the things that Poetry will help you do essentially is to automate the creation of this TOML file, so you don't need to manually write it. And then also it will, at the same time, install those dependencies and also create the virtual environments. So essentially, with the poetry install command, and it just kind of simplifies the process. So let's say you add a dependency at one point. Let's say you realize you need PyTorch. Instead of having to do pip install PyTorch and then editing your requirements file, you just have to run one command, poetry add PyTorch, and then that will install PyTorch, but then also add it to your TOML file. So then you kind of avoid missing some dependencies that are required for your project. So if you don't have poetry installed, what I suggest, trying it now on your computer. So you can run pipx install poetry. So first you have to install pipx. So this is one reason why I prefer UV. UV doesn't require it. But let me see if they still require using pipx. Yes, they do. But yeah, essentially the way you can install pipx is described here. So let me make this bigger. If you have brew on macOS, you can do this. For Linux, these are the steps to install pipx, and for Windows, these are the steps. And then once you have pipx installed, which is kind of a variant, something similar to pip, you can do pipx install poetry. All right. So yeah, if you've cloned PyDev tips to your question. I don't have a good answer for that, unfortunately. I think maybe it has to do with the issues that there are with pip, like Python 2 and Python 3. I think, but I'm not entirely sure. But because of this extra step of pipx, it's another reason why I've switched more to using VU, because it's easier for other collaborators that I have that are not computer scientists to use something where they can just use normal pip, or just normal pip. So you can also already run this step if you want. So for UV, they also say you can use pipx, or you can also just try this from your computer now, pip install UV, which we'll see later on in the workshop. But UV and poetry are kind of going to do similar things in terms of helping managing your projects. I think I'll still turn on the lights here because it seems like it's getting quite dark. All right. Okay, so these were the steps that we saw before. If you wanted to essentially clone, if you were doing everything on the terminal, you would clone the repo, you would create this virtual environment, you would activate it. Hold on. Oh no, these are the steps now, actually, sorry. So, and then here I'm using poetry install, and then this is for installing these commit hooks, which are going to help with formatting, and then running tests. So if you've cloned if you've cloned the repo locally, you can run these steps if you have poetry installed. If you don't have poetry installed, you can run the steps essentially that are here. So this would create the version environment. And so with poetry, you just have to run this first step essentially, and it would automatically create a virtual environment if you type in the .venv folder. So for example, if I go to my command line, I think we should be able to see that. I think I have poetry still installed if I haven't replaced it with UV. Yeah. So then if I run poetry env info, was it with this will show me, okay, when I run poetry, essentially, what virtual environment's using. So it's created by default the virtual environment inside the project, and also installed all the dependencies. Let's say if I need Python or NumPy or PyTorch or whatnot. All right. Any questions on that? Sorry, things may have been unclear. because you have switched to UV now. Yeah.
You install poetry while you're inside an environment?
No, you can install it in your main Python, essentially. Yeah. So that means, yeah, you would have run the pipx install outside of an environment. So whenever you see that I use these like parentheses, it means I'm inside an environment. But poetry I would have installed like in my base Python. And same with UV too. So then when you then make virtual environments, UV and poetry can still be used without having to reinstall UV and poetry each time. Any questions? Yeah.
If I understand correctly, poetry creates a virtual environment and the tumble file and kind of just does all that painful work for us, but it does the same thing.
So it doesn't. It's when you initialize with poetry, it will create the tumble file, and then also the virtual environment. And then whenever you run this poetry add command, that's then going to add new dependencies. If you're just taking a project from off the shelf, I would probably generally recommend using the setup instructions that they give, because maybe they don't suggest using poetry or UV. Maybe they just use normal pip or another engine for building the project. This is more if you're going to start something from scratch or if another project is using poetry or UV already. But from scratch, I would stick with using UV. Yeah.
So when you install poetry in your base environment, is there like a recommendation for the version of Python you should have?
So, I mean, that's kind of the nice thing about using poetry is that it's a bit more straightforward if you want to change to like Python 3.x, different versions, or for some reason you want to go to Python 2. And essentially it's inside your Py project toml that you define the Python version. So poetry is going to check which version you want, and then it's going to create the virtual environment with that with all the dependencies. Did I answer your question? Or?
But you said you install poetry outside an environment.
Yeah.
It still needs Python.
So I think, but maybe that's what the pipx helps with. Poetry is going to fetch the version of Python that you need. So, because that's the annoying thing with pip, that sometimes you need pip 2, pip 3, but poetry is kind of agnostic to that, so you don't get into those issues. All right. Any other questions? They're good questions. Okay. All right. So on the IDE side, so how many of you use VS Code? I forgot to ask this. Okay. So hopefully you have that open up. And so there's other variants which are useful. So that are nice, PyCharm, Replit, Spider, which we talked about last week. Or if you want something that's on steroids, you can use something, what's that, Cursor AI, which is just going to autocomplete like crazy for you. But what are the benefits of using IDE? So one of them, instead of trying to use text files, is that it's going to highlight certain syntax so that, okay, you can know what's a function, what's a variable, what's an object. And then it's going to help with indexing, which means that, okay, you can easily click between different variables and functions to know where it was first created, where else it was created or used in the project. So for example, if you need to rename a function everywhere in your project and you have 100 files, you don't want to have to manually go through each files, but the IDE will give you an option where you say rename everywhere else, which can be super nice. And then there's a lot of interesting plugins in most IDEs. So one of them that we'll see, for example, is GitHub Copilot, which I think many people are adopting now in their workflow to help speed up. So we had this joke last week. Don't make your life complicated. Get an ID. How many of you know who this is? Or you're too young for this? Okay, most of you know. Okay, good, still no. So some things on VS Code. So here are the links to install it in case you don't have it already for different OSs. And as we saw, we can open a project this way or clone a GitHub repo, as we saw with PyDevTips. And then let's say now that you've created your virtual environment, the place that you would set it so that you can then do everything within the IDE is in the bottom right corner. So there you can set the virtual environment that you've created either with Poetry or if you used Conda or pip or virtual env, sorry. And yeah, as I mentioned, if you're using Poetry, you can look up where your environment's file path is. So it was here, and then you can essentially copy that path when it asks it for you from VS Code. And yeah, so if you don't see it, so I think I've had this question before. It may be that you don't have a Python file that's open. So make sure you have a Python file that's open so that you can then click the correct click the version of Python in the version environment that you want. So you can also create a virtual environment from VS Code. If you go through that approach, essentially these are the screenshots of how that would happen. To choose which library you want to use, like we saw via the command line, and then pick the version of Python. Okay, so then navigating through VS Code. So I mentioned this thing about indexing. So if you want to rename a variable or a function, essentially what you can do is you right-click it, and there's this rename symbol option, which will just rename it everywhere for you so that you can avoid bugs that may come up if you renamed it one in the source code but forgot to rename it in scripts. So that's super useful. Yeah, so in that same file, it will highlight where that class or function is being used as well. All right, and then one thing which people maybe know is useful in IDs, but still resort to print statements is debugging. So how many of you still use print statements? Can be honest. Okay, I do too sometimes. Sometimes it just feels the easiest, quickest thing to do. But when you have code before that print statement that takes 5 minutes, 10 minutes, 20 minutes to run, I think we can see how this starts to get a bit inefficient. So what I'll show here is how we can do debugging from VS Code, so we can avoid having print statements in our code and maybe leaving them by accident and having random stuff printing all the time. So essentially the steps are, you go to, let's say, the function or the place which you're uncertain about. You make a little red dot. Make sure the correct version of Python is set. So this is the virtual environment that I created for this project. And then there is essentially like this play button on the top right corner where it may be defaulting to run Python file, but what we're going to select is debug Python file. And so essentially that's going to run your script until that breakpoints. And make sure to do this from a script, not from the source code itself, because you need something that's calling the source code. So for example, here, if you open up the project, there's this real convolve file. Let me show that where that is. Why does not, let's see, okay. So this is real convolve file, which is under the examples folder. So this is the file I'm running and making sure that my environment is set. And here you see there's not that little bug sign. So here's where I have to make sure there's debug Python file. So I see they've changed the interface since I made the slides. So then if I go back to the slides, it'll run the script until this breakpoint that I've set, and it'll stop there and be highlighted in yellow. And what's nice here is now I have a little terminal where then I can see what are the values of these different parameters to see, okay, if they're what I expect. I can also I can plot certain things to check that, okay, let's say the shape of something makes sense as well too. And then you can continue line by line or to the next breakpoint if you've set another breakpoint somewhere in your code. So that's how you would use debugger, and this can usually be a more efficient way to figure out, okay, what's the issue or why you're not getting the results that you're expecting. So I think these points are just saying what I mentioned. So there's a debug console where you can check the values of different things. You can also see the variables in the top left. And yeah, you can plot variables if you want to see that they make sense or not. Yeah.
I can add on this. Let's say if you can do some conditional breakpoints. So let's say you have a for loop that's going to run 1,000 times, but you just want to break on one, like let's say when I is equal to 562.
Yeah.
You can just set that as a condition for breakpoints.
Okay, where would you do that? From VS Code?
I have no idea.
Okay, but when in doubt, Google or ChatGPT, I guess these days, to see how do you set the conditional breakpoints.
You can also, if you go back on the previous slide.
Yeah. Yeah, I also thought of something that I don't think is in the slides, which I'll show.
On the left bar, the watch thing.
Yeah.
You can watch a variable.
Yeah, as you progress, yeah. So that's useful. The other thing are debugging configs. So let's say you need to set certain, you're comparing two different configurations for, say, two different experiments. Instead of having to manually tweak variables, you can just kind of preset these configurations. So I say, okay, I want to debug this situation. I want to debug this situation, this situation, this situation. So you can swap between debugging. So I don't use that feature so often, but if I see, I think when we were here, this is probably here, create a launch JSON, so that's how you can create a different setting for configuring. Usually you need a command line interface for your script, which we'll show in just a bit. All right, so these are what I was saying before, but okay, stepping through one line at a time or skipping over to the next breakpoints. Any questions on debugging? Anyone want to see it live? Yeah, okay. Hopefully I don't get any demo effects. Let's see. So maybe you can follow along if you have it also, this project installed. So I'm at this real convolve, but now I'm going to go to, let's say, one of the functions. Now we can see some feature of the IDE. So I want to go inside this function because I think there's maybe a problem in there. So what I'm pressing on my computer now, if you're on a Mac, is Command. And then you see how now I can click on different things here. It'll take me to kind of the source of where it's defined. So I'm clicking Command and I'm pressing RFFT convolve. So then it's going to go to where that class is declared. And I'm going to put a breakpoint here. All right. Let me close some things here. Close others. So let me close this one and close others here. Okay. So if I go here, let's see if you were paying attention. What should I do? Okay, let's do this. So why I know I want to see if people so why didn't I didn't stop at the breakpoint. I did something tricky here. I asked you about one thing, but there's actually something else. What didn't I do? So I'm running it I set the breakpoints and I'm running debug, but it's not working. Okay, you have an idea?
Maybe it's not the right environment.
The environment is set correctly.
Run it from the other file.
Exactly, yeah, I have to run it from this file. Because here there's no main function that's really being running that calls this class. But I have to run it from here, which is what's going to call and enter into that breakpoint. Is that what you had in mind, Adelia? Okay, got to test him, you know. Last year he came to all of our workshops, and then he would just like answer everything, and then we have a quiz at the end, which you'll see. We get first place in all the quizzes, taking away all the prizes from people. So there's prizes for the quiz, so pay attention as well too. But yeah, but now we don't let him do quizzes. We made him join LauzHack, so he can't do this. All right, okay. So what I have to do, as was pointed out, is I have to run debug from the script that calls it, and now we see that it's highlighted in yellow, that I've entered that class or this method in that class which has that. Okay, and this may be a thing that may not be obvious, but this window is open, but I don't see that interactive terminal. So where I have to go is debug console. And then this is where I get this window to play around with stuff. So for example, here I can see self.filter. Let's see what that is. I can see some values. Let's see if I have matplotlib installed or imported or not. So I need to import matplotlib. Oop, no. Now I can plot, yeah, it's just a flat thing with constant values. And then here are different steps. So if I want to stop everything altogether, this would continue. So run through the rest of the script. So let's see what happens. I think that should give some plots normally. No, it doesn't plot anything. We'll see what it does in a bit. There's some other stuff funny, cool stuff that the script is doing. But yeah, those are kind of, let's say, the little things to keep in mind when you're trying to run the debugger. Run it from the correct file, knowing which window to do the debugging from, and yeah. Was there something else that someone wanted to see from the debugging? Was that helpful? Okay. So hopefully that convinces you on the ease of doing it. All right, let's talk about plugins then. So essentially I'll just show one, which is probably the one that most people install. Okay, there's multiple that I install. Copilots, if you do Jupyter notebooks, which you'll find out later, I'm not a huge fan of, you have to install an extension for it there. So yeah, let's see GitHub Copilot, for example. So I think, okay, this is an old slide. So it's free for students, but now from what was it you, Adrien, or was Fan who was saying that it's free for everyone, I think now. So I guess they don't want to lose customers, so that's why they've done it. But in any case, I'd put another free alternative here. But there's so many companies that have these code assistants. So GitHub, they were smart to be early, so I've gotten hooked on that. So for example, if you're using something like this, what you'll see is that there'll be this grayed out piece of code while you're typing. And essentially those are code suggestions based on what's been written above or based on what's in other files. And then you can simply press tab to accept it. And what I think it's super useful for is for writing documentation. So after I've written my code, I'll add the doc strings, which are essentially explaining what are the inputs and outputs of the function. I just have to open these 3 quotations, new line, and essentially kind of gives a suggestion already, which is super useful. And if you're also then creating code for other people to use, it's nice to have that extra documentation, and cool that Copilot can generate that for you just from looking at your code. So I think a lot of the doc strings in this like dummy project for PyDev tips were essentially created with Copilot. And what it's also useful for is, let's say I want to do some quick prototyping scripts. What I'll do sometimes, okay, I could write with pen and paper to say, okay, what are the different steps I want to do? Or I can write it as comments. And then Copilot, if it has enough context, can then write the corresponding lines of code. So for example, for this real convolve file, I've added some extra stuff on top of it, but the main part of it essentially was written with Copilot with me just giving these commands, maybe tweaking the inputs for those commands. Create a signal, create a moving average filter, do the plotting. And this is super useful because especially with packages like matplotlib or NumPy, which are super well indexed, it avoids me from having to switch to, let's say, Google. Okay, how do I do a subplot, for example? I often forget that. So I just say, okay, create 3 subplots, and bam, it does it for me. And then also, what's the syntax for calling the different axes or the different subplots to plot them? So it's super useful for these very common packages like NumPy, matplotlib, PyTorch, etc. So yeah, if you don't have Copilot installed, give it a shot. I think like 3 or 5x how fast I write code, but maybe also how fast I introduce bugs. So that's another thing to be careful of as well. Yeah, any questions on that? Anyone want to see a demo of what it tries to output when I do random commands? Yes? Okay, let's try doing a script. I have no promises of what it'll give. So let's say, so now you can see how I create a file. So I'm inside my examples folder. I'll click this option to make a new file. Copilot, let's call it .py. All right, so import libraries. Let's see what it says. Okay, that's not what I want, so I'm not going to take it. Import numpy as np. So yeah, let's try to create 2D signal this time. Let's see if we can figure it out. Now it's doing some very strange stuff. So I'll do escape. I don't want that. So escape is how you can take its suggestion. Say x equals, okay, there, creates 2D signal. Okay, yeah, I want to do a 2D filter. That's kind of what I would do. I want a little space there. So it's going to create this filter, create convolver. So the reason why it's now doing those is because it knows that I did a similar example in another file. So it knows I did a 1D example, and now it's trying to do a 2D example of the same thing. And yeah, here it's calling NumPy's implementation of this. And I don't know why it's adding those weird things there. So this is terrible. Look at this. I don't know what's going on here. So yeah, it can hallucinate in weird ways, but so you need to kind of massage it. Obviously not accept everything it takes, and you can just escape. And if you're really getting annoyed with it, you can just turn the guy off altogether. Where was it? They used to have a disable, which was much easier to access. Now they want you to be stuck with it. Okay, classic. Okay, let's go back to the slides. So yeah, usually in the beginning, it doesn't really know the full context, but yeah, when you start to get into a code that's built up around it, it starts to be useful. One like really annoying thing, like when you want to index 2D objects or 3D, 4D objects, this is super useful that it can kind of keep track of, okay, where is the correct place to index a complicated tensor. So any other questions otherwise? All right, so now I'm going to show one of my favorite tools and why I have so much ire for Jupyter Notebooks. How many of you have used something called Hydra before or know of it? Okay, this guy put his hand up proud. Do you like it?
Yes.
Nice.
Your article that got me onto it.
Oh, really? Okay, cool. Nice. So you started using it already? And what do you find useful about it?
I'm currently doing a lot of the multi-run.
Okay.
So you can just put a set of parameters and it does every single possible combination applied to your function.
Like a grid search of
Yes,
inputs. Yeah.
Then you just get a bunch of output files and you can plot them and
So yeah,
whatever.
the output files is a really neat feature, which we'll see. Anyone else has used it and has something they've liked about it? Okay. Otherwise, let's see. So the main idea of Hydra, I think, but there's a weird thing about it is that it does so many features. If you just tell one of them, it doesn't sound really convincing. Like, okay, why would I switch to it? But I think it's the sum of it all that makes it really cool. So I mentioned my hates, not my hates, my battle with Jupyter Notebooks. How many of you have entered a situation where you run a cell and then you run some more later on, you tweak a parameter and you realize, oh shoot, this cell now needs to be updated. Does that sound familiar? Okay, so that's why I don't like Jupyter Notebooks for avoiding such type of bugs. Because maybe you think you got something working until you realize, okay, when I run it from scratch, okay, actually, it's not what I'm expecting. Or yeah, just variables not updating correctly. So that kind of pushed me to then focus more on relying on scripts for some prototyping tasks. And then maybe when I want to do a demo, then I use a Jupyter Notebook because then you can get this nice mix of images, text, and code. So for, let's say, experiments that don't, I would say especially like if you want to train a model or something, some people would do that through Jupyter Notebook. I would say, okay, no, better to switch this. And what's useful for in that context is that you're probably going to have tens, hundreds of different hyperparameters that you can set for that model. So what's your name again? Sorry. In the center, yeah. Yeah. What Matt was saying, he has this huge set of parameters that he wants to try and test. So let's say you have a similar thing for, let's say, something you're trying to train or in an experiment. Instead of having to manually tweak all those things in Jupyter Notebook, we're going to separate all of those configurations into a separate file and have a file for our code. So that's one of the main ideas which I liked about it, separating configuration from code. And then this is also, if we think about version control, it's good for version control because then we're not going to have like these little lines where we just tweak one thing because we just changed a parameter. Or maybe our collaborators want to run an experiment with a certain set of parameters. I don't override their parameters instead of having like a huge, maybe you've had this if you do some experiments or ML projects, you have a huge thing in the beginning, which is all of these parameters, and you comment and uncomment blocks of code for parameters. I see some heads nodding. So this is one thing that Hydra helps to avoid, where you can avoid those huge blocks of commented code and really have a separate file for each of those configurations and avoid overriding someone else's configurations. And the other nice thing is that when you use Hydra, it's going to give you a free command line interface. So how many of you have used argparse or click? Okay, so with a tool like this, argparse, essentially you need to have one line per let's say parameter, right? And then the same issue we have with the hyperparameters. Now half your code is just argparse and click. I'm sure argparse is super happy to have their name spread around, but what's super nice with Hydra is that all of that huge list of hyperparameters condenses to just one line. Because what Hydra is going to do is going to say, I'm going to look now into that file for all those hyperparameters. And then you can also set those hyperparameters from the command line. So we'll see that in a bit. And another thing that Matt mentioned is Hydra by default is going to create output files, output folders. So it's going to automatically create a folder with a timestamp and a date. So let's say you ran an experiment a week ago and you saved your results into that folder. If you forgot about what those results were or how you reproduced it, you can go back to that week and then see, okay, this is the output and these are the parameters I run. So we'll also see that. So I guess Matt found this article. So I tried to sum up some of those features, but let's look at some of them with Hydra. So first and feel free to raise your hand if you have questions. So on the command line interface, I was saying everything gets replaced with one line. This is that one line. So you need to import Hydra, of course. Hydra.main, and essentially you're just putting the path to where you've stored that configuration file. So if we go back to the RFFT convolve thing, so I put this config folder in the same place as RFFT convolve. So whenever I was running real convolve, or if you were running it, essentially it was taking the default parameters from here, where I've defined a random seed, the length of the signal, and the length of the filter. So we saw that Copilot was trying to generate some of those stuff. Okay. And then some other things that I add into that config file are, okay, some things to kind of, for logging, just to kind of print some messages. And this thing I add in all of my things where it's that, okay, usually when you run a script, let's say I ran it from, if I run Python here, it's going to run it in this folder. This line essentially is just switching to the output folder so that if I want to save results, it's going to save it into that output folder. We'll talk about the output folder maybe next slide. We'll see. So those are some configs. You can just copy them if you want to use some of the ones that I already use. And then essentially, another nice feature is that, okay, let's say you have this base configuration, which has hundreds of parameters, thousands of parameters, who knows? What's a nice thing about Hydra is instead of creating a new file with all of those parameters, you can create a new file with just the ones that changed from the default configuration. So for example, here, that's what the defaults does. And then I'm overriding the length of the filter. So let's say you had a file with, in this file, there were just 3 parameters. So it didn't seem so interesting. But let's say I had 1,000 parameters. I want to mostly keep them the same, and I want to make this config easy to read. I can just add 3 parameters. That's okay. And name, let's say this, here I call it X1. You can say filter length experiment to give it a more meaningful name. So on these output folders, so I mentioned that it's going to create a date and timestamped folder. So essentially, when I run the script, so we can go back to VS Code. Whenever I ran the script, inside outputs, which it will create for the first time, it's going to create a date stamp folder. And if I wanted to go back to, let's say, an experiment I did in August, now I can see that. Here are the ones I was running today. And then we can see, so this is why no plot showed up, because I was saving it into this folder. Here we can see the results of this convolution. And let's say I was like, oh man, I don't like this result, but I do remember 6 months ago, I had a better result. Okay, let me go to that folder here. Okay, I need to now figure out which other one ran it. So this is not, let's say I found it, okay. Because I was doing some other experiments here. You can also rename the folder so they're more meaningful than just timestamps. What's nice is, okay, let's say I found it, I said, oh yeah, that's the plot I was looking for. And I said, okay, but now what hyperparameters did I run with it? This is the cool thing with Hydra. There's this .hydra folder. I open it up, I can see the parameters I ran for that experiment. So then I can go back, and if I lost track of those, if I overwrote them, someone else, my annoying friend, changed in the Git or the Git history, I can at least go back to my local computer and see the parameters I ran for it. So for me, this is amazing for reproducibility and just going back to previous results. So I think I was mentioning this, looking for what hyperparameters I ran before, and yeah. Yeah, question?
We use Git and Hydra at the same time because our friends can see what can use Hydra too. Do they need to install it on their ID?
So there were multiple things to answer there. So Hydra, yeah, you would install inside your virtual environment instead. And you could have it then as a dependency in your Pi project. I don't know if I have it here in the Pi project. Let me see. So yeah, Hydra is here. So that means now if my collaborators install a package, they'll have Hydra installed in this case. Maybe sometimes you don't want it because it's not really necessary for the core code. It's more for scripts. Still have it. But on the results I have, they won't necessarily have it. Because usually this output folder is something I would keep in the git ignore file. So yeah, because maybe I'll have thousands of files there because you saw it storing all of this configuration. This is probably something better to keep out of your Git repo. So I wouldn't recommend sharing the outputs folder to your collaborators. But you can then still share a specific date result in another manner, or if you want to push certain results, which you think, okay, are good benchmarks, then you can still push those. But in general, I would put this in the git ignore file. Did that answer all the questions? Yeah, okay. Any other question? Okay, I think that's all I have for Hydra, but otherwise on Hydra, if you go to this blog post, I tried to make it more clear with different examples to show how it's useful for different features. Separating configuration from code, a nice command line interface, being able to handle multiple configurations simultaneously or not forgetting about them, and these automated output folders. Okay. All right. So this was more on so everything we've seen so far is okay, how to make our workflow smooth, reproducible, and easy to share with our collaborators, and also easy to go back to previous results as well. Now we're going to see actually more on the Python side of things. Okay, what are quick tricks that you can use to speed up your code? Obviously, depending on most of it is depending on the hardware you have available as well too. So one thing is, if you're using libraries like PyTorch or NumPy, is to really rely on vectorization and broadcasting. What that means is avoiding for loops. Like maybe you're, I think this example script shows it best. Let me go there. I mean, this is a really dumb example, but it gets trickier for more intricate examples. So in this case, I'm just trying to add, I've created 2 vectors, and then I'm just adding their values. Obviously, it's probably obvious to you. Maybe, I don't know if it's not, but it's going to be slower if you just do the loops to add each individual file. What's better instead is, okay, to just make sure they're the correct shape. Sometimes if one thing is 2D, one thing is 1D, you need to add an empty dimension along one thing. I think maybe that's shown here, yeah. So here I'm adding a 1D thing to a 2D thing. Instead of just adding it one at a time, you can rely on broadcasting so that it'll just copy over that column vector, for example, and add it to each other column vector in A. So yeah, I mean, simple stuff like this. And if you're stuck, again, I think Copilot or ChatGPT is great for this. Okay, how can I vectorize? How can I use broadcasting to more efficiently do this? Because if you're looping over huge tensors, this can slow down things. And here are just some of the example timings to see how that could be the case. Okay, so applying FFT along axis. Sorry, I kind of forget what each example is done. It's been a while, but essentially taking advantage of the fact that, okay, you can vectorize things rather than for loops, and then allow one operation to kind of just be copied over multiple dimensions. And here are just some examples of that. But those are some simple things on using NumPy and PyTorch. Another library that I find myself using often, which is surprisingly easy to use, is something called joblib. How many of you are familiar with joblib? So this, okay, now this guy's on top of his game. Why are you at this workshop? You should be teaching it, man. But so the idea of joblib is that most computers, they have multiple cores. So like 4, 8 cores, I don't know, depends on how old your computer is. And if you have a task that can be done in parallel, let's say you're trying to do multiple simulations. So this was the context that I was doing. And each of those simulations are independent. Instead of waiting, and you're looping over 100 different simulations, instead of doing one after the other, you can actually, without any GPUs, so this is just on CPUs, you can parallelize it over multiple cores. So maybe a library that's more common for this is multi-processing, I think, in Python. But joblib just makes it so much easier. So essentially, the one line of code you need to add is this, where it's this object from joblib. You say how many CPUs you want to use, maybe just max out all the CPUs on your computer. And then you have to define a function, which then can be ran in parallel. So instead of running this function one at a time, for example, for one seed at a time for, I don't know, 100 times, it'll just try to spread them all out and then bring back all the results together with this one line. So for example, in this case, when I was looping over something, the speedup will depend on the number of cores you have. So here, I guess I have 4 cores, I guess, which is why there was a speedup of 3 point something. Another thing is, or any questions on joblib? So this is something when I want to just get quick parallel things, it's an easy thing to add in and try in a script. The other thing is you can then also use GPUs. So you can either do that directly by implementing your stuff in PyTorch or TensorFlow or JAX or any of these libraries. But maybe one annoying thing about those libraries is that there's a lot more to those libraries than just GPU support, because they're also keeping track of gradients to do back propagation. So an alternative library, which maybe not so many people know, is CuPy. Do you know CuPy? Okay, I got him on one. So CuPy essentially tries to imitate NumPy and just allows you to then do those functions on GPU. So JAX tries to do that similar as well too now. So they have JAX.NumPy, I think, is where you can have all these submodules which are similar to NumPy. But CuPy is at least a much lighter weight library to use GPUs. So yeah, for GPU support, again, this depends on your GPU. But the way I would use CuPy in some projects, if it was a project where you didn't want to install a full-blown ML library, would be that since CuPy just tries to imitate the API of NumPy, you just have to do this trick. So this is the boilerplate you have to copy. Okay, you first detect if the input array is a NumPy or a CuPy array, so if it's on a CPU or GPU essentially, and then you use the corresponding function. So the normal one would be scipy.ft, or the normal as in CPU version, and the GPU version would be calling it from this submodule of CuPy. Yeah, one library you could use instead of PyTorch and the ML libraries for GPU support. Any questions on that? Okay, going quick through some stuff. So let's talk about packaging. So let's say you built your project and now you want to make it pip installable so that other people on the internet can install your project, or even if you want to do a local package. So the general structure for packaging a project has this like source code folder. Here I call it PyDevTips, and this init file, which can be empty. And then you put your source code files inside it. So if you're using something like Poetry or UV, so one of the nice features about this is that when you initialize a project with Poetry, I think it's like Poetry init maybe, or Poetry new, this will create that folder. And then also all the boilerplates, what I mean by boilerplates, all these necessary files that you need. So you don't need to manually create those files. So it's going to automatically create the TOML file, the README if you don't have it already from GitHub. So this is and then it would also create that source code folder with the init folder. And then it also tries to encourage you to write tests, which is always good. So this is one neat feature Poetry, but also UV will do this. It will generate that boilerplate stuff. So looking into this Pi project TOML, so I think we took a peek at one point when someone asked about Hydra. So here is essentially the configuration for Poetry. So here I'm just saying the version of my particular package, what license it is, where the README is. Here I'm giving all the dependencies. So the version of Python it needs, versions of different Python packages. And then you can also install these different groups. So these groups are, for example, let's say there's libraries that you need more for development purposes. So we spoke about these code formatting libraries. You don't want those to be installed if someone just wants to use your package as is. But if someone is developing code, you'd probably want to push them to install it. So then there's like a flag that you can use. And then here it's essentially saying which engine it's using to create to package your library. So here it could be Poetry, it could be UV, it could be other things. Yes. Any questions on this structure? Okay. And I think what I mentioned previously is that when you're in your project and you do this Poetry add command, essentially it's adding this new line for that package. So you don't need to manually edit this file. And so in this case, I had created this group called dev. So if you were paying attention when I was installing my package, I put this dev flag to install all those code formatting stuff as well. And then I had to run this command as well then, which we'll talk about in a bit. Or now, I guess. So for code formatting, so not a fun thing to do. So automate it. Don't just try to let the tools do as much as possible. But essentially, there's just to kind of give you some concepts. So there is this style guide. I'm not sure if it's this one or another one that most of the code formatters try to stick to. And then there's these different tools, which then help you to check if you're sticking to that guide. So Flake 8 is going to check what are those problems. It's not going to solve them. Black is going to try to solve them. So maybe fix the spacing, indenting of some things. And another common one is isort, which will, there's a, let's say, convention of how you should order your import. So it's going to try to put those in a more conventional order. So essentially, these are the main tools, but all of those can also be grouped into a single one when you use tools like UV and rough, but I'll come to that a bit later. But essentially, there's individual tools for each of these parts of formatting. So kind of figuring out the spacing of things, and then also kind of how you name your variables, the lowercase, uppercase. Black won't fix that, but Flake 8 may point out some of those things. So yeah, rely on these tools to do it, and then do the rest. And what's nice that Flake 8 will tell you what are those what are the rest of those things to fix. So the best way to run these tools is actually when you're committing to a project. What these pre-commit hooks will do is that when you try to do a git commit message, it's not going to let you commit unless you've fixed these formatting issues, or unless Black or these other format linters have fixed it. So this is what it would look like. Let's say I tried committing a file and it says it failed. It had to reformat these, and then that's what Black fixed then. But then there are still some things that Flake was complaining about. For example, the length of a certain line. So then what I have to do is Black has modified those files. So now I need to re-add those files and then do my commit message again, and then things will pass. So let me show that concretely, because I guess probably some of you want to see me struggle to do these changes. So let's say I have this script here that we've looked at before. Okay. Let's say I'm going to add some weird spacing stuff like this, and then let me do this. You'll see why in a bit. Okay, so should I do command line or from here? Let's do from the command line. So what we saw in IDE is there's these different buttons you can press. Who prefers, can do both. Who prefers that I do it from command line and from the VS Code? It's quite split. So what to do? Okay, let me flip a sticker. If it falls on red, VS Code. On this side, we'll do terminal. What was right again? Okay, let's do VS Code then. Okay, so VS Code. Okay, so there are also some IDE things, because it's better. Okay, oh yeah, this is probably better so that you see how you can really stick to everything in IDE. So I've updated this. I can see what things have changed. I looked at it quickly. I didn't realize, okay, there are probably terrible things to add. So let me add that. I hope I have the pre-commit hooks installed. So now adding it will be, there's no issue. The issue should come up when I try doing the commit message. So I'd say terrible commit message changes. I'm going to also type it wrong. So that's just terrible commits. Okay, so good. I installed pre-commit hooks. So if I didn't, so now that I've installed them, instead of what we saw in the terminal where it's going to complain, I'm going to get this error message. And then I can look at the output to see what the problems are. So, Black couldn't reformat it, poor guy. So let's see what happens here. Cannot reformat real convolve. I probably introduced the bug when I did that. That's why. So this is the nice thing about using IDE. So I can unstage this now and then remove those changes. I can still see those changes that have happened. Let me remove. Yes. Okay, now it's back to the original. Let me try this, just that. Okay, now we see that it's modified. You guys got it. You're making me struggle here. Okay, let's add it now. Let's try and commit. Okay, so now we see that it's reformatted the file. So now it's back to the original version. So if I click on here, I'll still see this change because this is the staged version. I'll try to make the distinction. Stage is what I tried to commit, but now Black made this new change where I put it back on one line. So there we can see Black fixing it. So now if I try to add it, actually everything will go away because now it's back to the original thing. So there's no reason for Git to push it. Let me do something a bit nastier now then. Let me add an F here. Okay. Now let me try the same thing. Show command output. So here we see Flake 8 failed. I didn't, for some reason, didn't say why it failed. Oh, it does? Ah, yeah, it says, okay, cool. Yeah. So here we can see Black passed because there's no issue, but there's something I introduced into the code, which is not convention. Whereas I tried to do this F string, where normally you only do that when you have a variable that you're going to print with that string. So for example, here I'm printing a file path. So what Flake is saying, so that, again, the tool that doesn't fix things but diagnoses, that is saying, okay, there's an issue at this line in this file. So then if I go there, I remove that F here. And then when I do try to push it again, we'll again see, okay, it disappears because now I haven't really made any change to the file. Did that make sense to people? Someone wants an alternative explanation? So essentially, yeah, these tools are going to be run in reverse. So first, Black will be run to fix things, and then Flake will then run to check to see if anything still is not up to convention, and then it'll spit out this error. Yeah.
But will these tools only look at formatting or also like optimizing the code?
Only formatting, so they won't optimize code.
Say if you've got like repeating same line of code, you can make it into a function. They won't catch that kind of stuff, right?
I don't think so, no. But it can complain sometimes if a function is too long. Like if you have too many lines of code inside a particular function. I think that's something it could complain about. Yeah, then you, sorry, yeah, there. The formatting? Yeah, so there's, I think I probably have it here. So here you can set the versions of the tools, but then you can also set, I forget where it is, which, yeah. Here you can set, okay, I want a certain line length to be longer than maybe the one that's typically expected. And then you can also tell it to ignore certain things that it won't like. So I guess I didn't ignore any of them here, but if I check into another project, so here you can tell, so this is another code parameter called rough. So what's nice about rough is that it combines all the other ones that we saw before. But here you can say ignore certain error messages if you don't like, if you find them a bit too constraining. So that's mainly what you can do in terms of personalization. Did you have something else in mind? Or, okay.
Do you install these tools just like you install any other library?
Yeah, so that's why in most of my let's say installation steps, when I share code with people, I add that as a separate line of code where either I put it in a flag, but then you also have to run this pre-commit install command because this is not enough. This is just installing the Python packages, and then this will set up the things inside your Git folder to then do those checks. So yeah, this I would do within your virtual environments. Any other questions? Yeah.
What is it you do in that commit book? Is it a name for the tool?
It's the name for essentially. So here, if you remember, when I was making those changes, I was writing commit message here, right? So it's called pre-commit because they're run before I press commit. So that's why it's called pre-commit. I call them hooks. I don't know why. It's maybe a software term for these type of functions. Any other questions? Okay, so hopefully, yeah, this dummy Python dev tips project shows you, okay, how you would kind of set the installation of those formatting tools within your projects, usually within a development group, and then how you would install it, which I think, yeah, it's described essentially in the README. Yeah, essentially installing the group, because if I didn't have this dev thing, it's not going to install Black, Flake8, and all this, and then running this command to make sure they're installed. Any other questions? Okay. All right, so we saw this. Okay, so now your code is clean. We didn't talk about tests, but hopefully you've implemented some tests. Now we're going to see, okay, how would you now publish it so that someone can write something like pip install PyDev tips, like you can do for this project. So the first thing that needs to be done is to create an account on PyPy, which is essentially what's called as a registry, or you can think of it as like this hub of all these Python projects. So it's free to do that. And essentially your account will have a specific token or password that you can then configure Poetry with, so that only you can push to that particular project. And there's something similar for UV as well too. And then the steps, so this is what you have to do just in the first time. So what you have to do the next times is when you want to push a new version, you would update the version number in PyProject. Let me show that again here. That's this version number. Because if you already have that version published, it won't let you override it normally. So you update that, you run Poetry build, Poetry publish, and then your project should be online. So I guess this will take online to this version 4. Do you need my card? So then people can then run this pip install PyDev tips. And that's essentially it, I think. So another aspect which you may want to add is that on your GitHub page, you may want to indicate that you have this newer release if you're maintaining an open source project. I always forget these steps. That's why I put them in slides like these so I can come back to it. But essentially, you have to create a new tag, which are things you do from the command line. And on GitHub page, you set the tag and link it essentially with that new version. And yeah, that's essentially it on publishing. That's really a future step thing. I don't know how far if you guys are on that side of things, but what's already nice is that when we do Poetry install, if you see from my script here, is that I can import my package as if it was NumPy. So essentially using Poetry or using UV lets you do that locally and also with other collaborators that you share. Because I was mentioning something about, I don't know if anyone, or let me go to not this version of it. I think I was mentioning to people that if you didn't have something like Poetry, you would have to do something like this. sys.append path. Does this seem familiar to anyone? So this is something you would normally have to do if you wanted to use your source code that you've defined in another file. But the nice thing about doing your project within Poetry or UV is that you don't need to do all this to find the source code for PyDev tips. It's already importable like this because PyDev tips is installed inside your virtual environment. Any questions? Okay. There's a couple other things I wanted to show. So these are the things I didn't get time to make slides for, but just kind of point you to them, and then we'll have a recording of this so then you can at least see how to do it. So last week we talked about how data sets is something that you don't want to push to a GitHub project, especially if it's like tens or hundreds of gigabytes. So a really useful tool for actually hosting data sets is Hugging Face. How many of you are familiar with Hugging Face? How many of you use it? What do you use it for? Like, if you can share, yeah, in the back. Yeah, pre-trained models, yeah. So I think that's the thing that it's most known for, but they do so many awesome stuff in open source. And one thing that's been really useful for me, like my PhD, is okay, I create data sets, how can I share those data sets with other people? So this example is just essentially showing you how can you make a data set and then store it on Hugging Face instead of putting it in a Google Drive folder or some other folder where people have to download it, figure out how to import it into their project. Hugging Face gives a really useful API to, once you've done this upload, you can just call this Python function to then have it as a data set like you would any for machine learning. So I started the process of adding it to PyDev tips. So the example, this is essentially the example of how you would use a Hugging Face data set. So essentially, there's this data sets library made by Hugging Face, and you just run load data sets, your Hugging Face username, the name of that data sets, and then whether it's to train or test splits, and then you can index it like you would data sets. And if we can go on Hugging Face to see what that data set looks like. So, which is another really cool thing about it. Oh, it doesn't exist anymore. Let me go to my, I think I wrote it incorrectly. Strange. I guess they changed how they were. Okay, but this is a nice thing. So essentially, when you find a data set that you like on Hugging Face, there's this command, use data sets with the datasets library. And essentially, you see that same line of code that I showed you before. So now other people can just easily download your data set without having to download from Google Drive, unzipping, blah, 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 whatever. So this is super useful and great for reproducibility too. And then what's really nice is that they give, you can preview your data set from Hugging Face. So if someone just want to see the contents of it, they don't need to download it, unzip it. Maybe it's tens and thousands of gigabytes, or I think the most you can do is 50 gigabytes. They don't have to unzip it to see what some of the things are. They can see some images. So here I just created some random noise, but you can add all sorts of different modalities. So images, audio, maybe it's a noisy thing. Oh yeah, sorry. I just created some noisy stuff. You can add text, you can add labels. So all that would be loaded essentially when I do this data 0. I get the audio, I get the image, I get the text. Really useful. So I use this I do some like computer vision type of tasks. So I use this to host and share my data sets. So that's about this. I guess here you can see the PR if you want to kind of see, okay, what some of those files look like. But yeah. The other thing, okay, which I mentioned before is UV. So this is something Poetry is still great. I'm using more UV now instead. Here essentially is the link of how you install it. What is this example again? Okay, this is an example of how you would then, similar to Poetry, essentially you have these flags like a dev flag, and you do the same stuff doing this pre-commit install if you had those commit hooks that you need to install. And then here's just like GitHub Actions, which I didn't cover in this workshop, but these are tests that you can run on GitHub. And this is an example of how you would do formatting. So essentially, check for formatting, install, yeah. Okay, quick links just to kind of show you some other stuff, which I use and would recommend, but didn't have time to incorporate. But so to conclude for the workshop, we start off with super basic stuff, creating virtual environments, how to use different features of an IDE, configuration management with Hydra, different libraries to optimize bits of your code, NumPy, joblib, QPy for using GPUs, packaging with Poetry, quickly with UV as well too. And so at this link, there's many more features, which there's not enough time in an hour and a half to go through, but there's also stuff on how would you make documentation that looks something like this. How would you write unit tests? So these are like the tests that essentially we're running when I do something like PyTest, and they would be defined in the tests folder. And then these things you could also add to your workflows in GitHub if you wanted to run tests, if you pushed code. How would you do remote development? So that's if you're coding on a server and you want to connect to it and still use VS Code. So a lot more stuff, essentially just kind of described in this menu down on the left-hand side. But that's it I have for the workshop. Thanks for your attention. Questions? Any questions? Yeah.
Hugging Face free to use, and you can upload as much.
You can. I have not faced any limits so far, but yeah, I think as I mentioned, the limit may be 50 gigabytes for the size of the data set. But I've seen in some threads there's some workarounds where you can then split your data set into multiple data sets and then combine them again. Yeah.
How do you get your data on Hugging Face?
So yeah, didn't show that, but yeah, essentially if we go, just so you know how to check it out later, So this was the example of using the data sets. So as you notice, I'm in a branch here. For creating the data sets, I have a template file here which shows how would you do it for those different modalities of images, text, audio. So the way you would create it is that they expect a specific structure for an object, which you would then send over to Hugging Face. So the creation, let's see if I can close this, yeah, would look something like this. Just kind of give you an example of it. So here, again, I'm using Hydra to configure how I upload the data sets. So let me upload the config so we can see that at the same time. Maybe I have it here as well too, so we can. What changes do I have? This is how you would switch a branch. So now I'm on the Hugging Face. So now where it is on that branch, which you can find on GitHub as well too. I'm just gonna do it here so it's easier to have side by side. So here's the config for Hugging Face. And then here's the script to create it. Oh, shoot. Yeah, there. Command B was what I did to remove this. Okay, so here, essentially the parameters I need to give is, okay, where in my account I want to write it. What's the random seed, if there's some randomness involved, the size of the test set, and here you would put your token, but you wouldn't want to upload this token to GitHub. That's something that should be secret for you. And then this is just some specific stuff that I did for this data set, but these are the main things that you need to define. And then in the script, so it needs, let's say, to create a dictionary where you essentially then store all of these components. And then in this dictionary, I pass it to this dataset object, which I think is coming from Hugging Face. Yeah. So I need to put it into this structure they're expecting, and then dataset. Okay, so this is the object I created, and then it's this push to hub command where I give the repo ID and my password essentially. And yeah, very technical stuff, but hopefully at least this like minimal example can show you for different types of content how you would do it. And then what I also showed an example for was, I won't play the audio again. So here I added some individual files as well too. And then what's nice about Hugging Face dataset, it's also a version control system like Git. So if you make changes to your data sets, you can go back to previous versions of it. So here you can see there were like 16 commits. Hopefully that points to where you can do it, at least. It's a bit technical to describe each line. Yeah.
So I understand properly, you have your data set locally.
Yeah.
But you then run that script.
Script similar to that, yeah.
Pushes it, I guess, to Hugging Face.
Exactly. Then you can delete it locally, and then essentially re-download it like this. And then what Hugging Face does is that when it downloads it, it stores it into some cache folder. I think it's something like ls. It's somewhere there. So if ever you run out of memory, you know where you can delete data sets. Any other questions? Yeah.
One quick question.
No worries.
But I just want to know where exactly is the data stored in this compliance with like or something like that. So that we cannot use or try to.
Yeah. So yeah, for sure. I mean, that's something you'd have to check on Hugging Face's documentation. Maybe there's a way you can specify a particular location for data sets. Luckily in my project, I don't have any sensitive data, so I'm a bit, I haven't dug into those aspects because I know that otherwise at EPFL, people use Swiss drive if they want something that's more Swiss stored or Swiss based. But yeah, obviously that's something to keep in mind, not just to upload any random data online.
Can you compare Hugging Face with another cloud server that you have, like stuff?
To do what, for example?
To upload the data.
Ah, okay. I'm not sure, but that's something to check. So they have a whole documentation for it to then see what is possible, what isn't possible. Let's see. Custom cloud server. Yeah, I don't see. I don't see something straight away, but something you can ask in the forum if it's a feature you need. Yeah.
And sorry, so when you upload everything into Hugging Face, you delete your local copy. You said that if you run the script that like is processing that data or is using that data, it downloads it into a cache folder.
Yeah, so it will download what you uploaded to the cache folder.
It'll download it
Yeah.
permanently. It won't just download it while it's running the script and get rid of it when it's done.
Usually doesn't. It keeps it there. I mean, maybe there's something you can configure, but in the experiments I've run, I've usually downloaded with the purpose of then keeping it later. So then your script doesn't have to go through the process of downloading again, because then it could take half an hour or so, which you may want to avoid. But there are options where you can download parts of a data set if you don't want to download the whole thing. Because if you go to Hugging Face, what you'll see is in this data folder that it creates, there's these thing called parquets. Here, it's a tiny data set, so there's only one for test and one for train. But maybe you'll have 15 different ones for train. And then when you load the data sets, like I showed, or like we saw here. Oh, no, not there, sorry. I think there's like an argument where you can give like an index 0 to 15, something like this, just load part of it. But maybe it's still, I may be wrong. It may still have to download the full data set, and it just loads that subset of the data set when you are using it in your script. Any other questions? All right, if not, do I have anything else? Otherwise, I have questions for you.